Good morning, everybody, and thank you very much for your time this morning and joining us for this presentation. We hope that at the end of the presentation you have a better understanding of how you can accelerate your application development and delivery using the Red Hat OpenShift Container Platform and AWS. So let's jump into that and let's talk about why customers are thinking about adopting platforms like OpenShift. Customers are more frequently realizing that their ability to get disrupted by smaller competitors is a reality. Companies are no longer secure. Big enterprise companies are no longer secure in their positions as the dominating force or the dominators within their industry. And any startup with one or two or three people in the garage can now disrupt the industry and completely change the way that the industry does business. And that is a direct threat to companies that hold a big position in that industry, and therefore they want to be able to be the same as these industry disrupting forces, like these small companies. And a few companies come to mind, right? If you think of big companies like Airbnb or Netflix that was capable of disrupting their industries. And when we look at companies like these, what is the fundamentals that the company works around that makes them capable of disrupting their industry in the way that they did and completely changing the way the industry works? The three categories or defining traits that we have identified that makes these businesses capable of doing what they are is basically coming down to elasticity, agility, and availability. So let's talk a little bit about availability. Availability in the information technology space is defined as high availability that allows you to always be operational for a desirably long length of time. So availability can be measured relative to the amount of time that your operation is running and is never failing. So how do you provide high availability? One of the key functions of high availability is to make sure that the infrastructure that you are running your applications on and your services on is geographically dispersed in a way that if for any reason one of your application infrastructure locations gets compromised, that you have a failover or that you can automatically recover in a secondary location. Now, traditionally, that is very difficult to do because having multiple data centers means that you need to have multiple personnel that will manage these data centers, and the costs are exceedingly growing for you to do something like that. So you tend to have maybe one or two smaller data centers that really limit your ability to be completely and truly high available. Amazon has taken this idea of high availability and we've grown it and made it easier for you and your customers to be highly available. And we do this through our abstraction or our concept of AWS regions. An AWS region is a location where we have a mesh of availability zones that have transit centers between them to provide redundant paths of transit between the data centers in each availability zone. Transit centers also connect to private links to our other AWS regions, which means that the data transfer between one AWS region and another AWS region is completely private, as well as secure and also optimized for less amount of latency and the best throughput speeds. We also have private links to customers in the form of things like Direct Connect, which allows you to have direct connections from on-premises data centers to our AWS regions, which allows you to run a true hybrid environment and see our AWS regions as an extension of your on-premises environment. And they are spaced in a geographically significant way so that every AZ within a region is less than 2 milliseconds apart. Usually it's less than a millisecond, but also at least geographically, physically spaced apart far enough so that any major disaster or impacting event won't take out a full region all at once. And the way that we do this is by having multiple availability zones in each region. So an availability zone is a regional cluster of discrete data centers. Each data center has a separate redundant power supply, networking, connectivity, and generating facility, which means that they're all completely standalone and independent from each other. All of our availability zones, or all of our regions, have at least two or more, and usually more, availability zones. Each availability zone is also not just one data center. Each availability zone has at least one or more data centers. Some AZs may have as many as 6 data centers inside of it. And each data center in an AZ is less than a quarter millisecond apart from each other. Our data centers typically host around 50,000 servers to around 80,000 servers. And we don't want to grow our data centers larger than 80,000 servers because we want to limit the blast radius that any impacting event might have on our availability zones or our data centers. So becoming highly available is a much easier concept in AWS because the infrastructure that you launch can be spanned across these availability zones, which will make sure that in any event of failure, you will be easily able to recover or have backups to recover from, or even fail over completely to have zero downtime in your environment. We provide native services that make this a lot easier for you as well. So our abstraction of your networking infrastructure through Amazon VPC allows you to easily manage the concept of availability zones by simply defining subnet zones and extensions of your private subnets and launching infrastructure into those subnets. And each subnet can be attached to a specific availability zone to make sure that when you do deploy your infrastructure that you are effectively dispersing your infrastructure over multiple AZs to make sure that you always have redundancy and availability. We also have services like AWS Shield and AWS Web Application Firewall, which is managed services that you can front in front of your running applications that will give you additional protection against things like DDoS attacks and security breaches. And that's a completely managed service by our security experts that you don't have to worry about and abstracts the requirement for that. We also have Amazon Route 53 that incorporates health checking and latency routing in our VPC environments to your infrastructure. So you can leverage Amazon Route 53 to always make sure that health checks are succeeding to your infrastructures in specific regions. And in case of a failure in a specific region or a specific AZ, then Amazon Route 53 will automatically change your DNS records to point to the healthy resources. So we have these native services that will make it a lot easier for you to stay highly available. Another aspect is elasticity. Now, elasticity is defined as the ability to which your system is able to adapt your workload to work together with the amount of requests that is coming into your applications. So how quickly can you respond to more users that need to access your service? And how quickly can you respond and go back or shrink to a previous state once that burst of activity has passed? We have some native services for elasticity that makes it easier for you to control your elasticity as well. And elasticity and high availability works hand in hand together. If you aren't able to furnish every request that comes in from your customers, you're no longer highly available. So you need to be able to scale up your infrastructure as the request count or the traffic to your application becomes more. And we have services like our AWS Autoscaling service that will monitor different metrics like your CPU and network and memory usage on your infrastructure. But you can also set custom scaling metrics in CloudWatch that you can use to scale against. That might be application-specific metrics that, for example, can be exposed through an application platform like OpenShift. And that will scale the infrastructure automatically on your behalf and make sure that your application is always available. Now, we also have managed services like SQS and SNS, which allows you to infinitely scale almost immediately by the amount of requests coming into those services without you needing to provision physical infrastructure or virtual machines. The way that we do that is the service is monitored and managed by AWS, and your applications can seamlessly interface with these services. So something like SQS, for example, which is a message brokering service, allows you to connect your application to that service and process messages that are produced and consumed by the service. So your infrastructure can then scale to the amount of messages that is in the queue, and you don't need to launch out new infrastructure to actually just manage the specific queuing service itself. So you can adapt at the rate that you want to process those messages and leave the scaling and the elasticity of that service to the managed service of Amazon Web Services, rather than having to manage that infrastructure on your own. A key factor, though, to all of this, when you combine elasticity and availability, is also your ability to be agile inside of your environment. Technical agility is the ability to quickly and smoothly adapt or integrate current technologies with your existing technologies or newer technologies that might be disruptive inside of your industry. The problem, though, is that traditionally, customers that already have an existing environment, or customers that already have an existing footprint with an existing set of developer skills and IT operation skills, are slow to be agile. They usually have a long development cycle time. It's difficult for them to scale, and it's very difficult for them to assume and adopt new technologies, because the developers and the IT operations aren't always speaking on the same level, and they're not usually communicating very effectively between each other. The developers usually have a very unique environment that they're developing their applications in, and when they pass this on to the IT operations teams, they don't know how to effectively deploy these applications to have the same experience that the developers had while they were developing it in their development environments. And for good reasons, because the IT operations teams wants to have an environment that they have full control over, that is as frugal as possible, so that allows them to save money. And obviously, security is paramount to the IT operations and security teams. So this disparity between the communications between the two teams usually leads to an inability to agilely or adapt new technologies and be agile in the way that they do business, and therefore fall behind the current trend of technological adoption, which allows smaller companies and smaller startups that are more agile to overtake them or become the de facto standard within their industry. So one of the ways that customers came across to, or what the industry has pivoted towards to make this problem easier and to almost solve all of this, is by the adoption of a container standard. So what is a container? Well, it really depends on which person is looking at what a container is. From an infrastructure side, it allows you to have a sandbox application process on a shared Linux OS kernel, which means that it is a portable environment that is always going to deploy in the same way and an expected way in any environment that it gets deployed in. From an application point of view, it allows you to package multiple applications and all of its dependencies easily into a single containing unit, and therefore deploy it to any environment using any number of continuous integration and continuous deployment methods. And therefore, it's easily accessible, and it's easy to share these containerized components between different business units. The containerized unit means that a developer can build it in any development environment that he wants, and then pass it on to the infrastructure team, and they will be able to deploy it as long as they understand the deployment method of containers. So what does this mean to you? It means that you are likely to be able to do smaller incrementations in a faster manner that allows you to deploy your applications with more confidence more frequently, and therefore adopt new technologies a lot faster and make your applications better and have your customers have a better experience. It'll always run the same that on your development environment, which could be your laptop, as it does on the cloud or in any environment that you deploy it in. And it'll streamline your development and deployment process. This also brings up the point that it makes it possible for you to have a choice of hybrid environments. If you have a legacy amount of technical debt inside of your data center, you can now deploy your applications with confidence in your on-premises environment as well as in the cloud, and know that it will always be the same experience for your customers. It also allows you to better integrate your security and allows you to make your applications more scalable across your environment and use the cloud, for example, as a burst mechanism to your existing infrastructure. So in order to really make this adoption of containers effective, you need to have a specific platform that encompasses all of the specific components. You need to have a host that is trusted and is enterprise grade, that allows you for the security and the confidence that you've come to know with the enterprise level of hosts or class of hosts that you have on premises. You need to be able to have a management platform where your operational teams can manage the access that is allotted and allowed within your infrastructure to make sure that when your developers are using your environments, that they are using it effectively and in a way that you want them to. You need to have a persistent storage layer and somehow to manage that storage across multiple container hosts in order to effectively make applications that do have stateful in this environment and be able to deploy applications like databases or any other application that requires some form of persistent state storage. This is usually the architecture that an application or a native or a legacy application would have been built. So your ability to attach storage to your containers is really important, and to manage that storage around it. And then lastly, you'd like a platform that does all of the automation and building and the continuous integration and distributing and the deployment of your applications in an automated manner, which allows you to run security and pen testing and all of those things in an automated manner as a part of your deployment workflow. So you will catch any security vulnerabilities or unsigned libraries or anything like that that might have made its way into a container way before it even reaches your production or even your test environment. So in steps, what we call the application platforms. Application platforms provide you with all of these benefits. It accelerates your development cycle. It makes it easier to adopt by all of your internal teams. It gives you the ability to iterate faster on your application development, and it gives everyone a unified experience, which means that you only need to learn one set of technologies, or you have the ability to give one set of technologies to all of your different business teams and development teams, yet allow them to independently choose the subset of technologies that they want to use to build their applications. So one team could build their application in Node, another in something like Golang or Rust or whatever technology they choose, yet their actual deployment and testing and management experience will all be one of a unified experience. A simple example of something like this with an application platform would be a developer that builds this application using something like Git and stores his source code in a Git repository. He then deploys it using a CI/CD engine that builds a container and then deploys that container onto multiple different environments. So we have worked very closely with the Red Hat OpenShift Container Platform and the team that develops this platform to allow the OpenShift Container Platform to be a native AWS citizen and have deeper integration with AWS and the services around it. So all of what we just spoke about, the trustless host that you would want for your environment, comes from the trust and the security that we've come to know from an operating system like Red Hat Enterprise Linux. So together with Red Hat Enterprise Linux or Project Atomic and the Atomic Host product that Red Hat has, you get the security of a trusted operating system that you can deploy your containers in. Kubernetes is the de facto standard for container orchestration, and therefore OpenShift is built on top of the orchestration engine that is known as Kubernetes, that allows you to easily manage network and storage and your container registry, as well as logs and monitoring and the security. On top of that, you get a unified developer experience that is a self-service experience. Your developers can provision services that they need and require on their own, and they will be able to require and request things like databases or messaging queues and those type of things without needing to reach out to the operations teams. It will therefore become easier for you to iterate quickly and to introduce new technologies in your applications because a developer can do it all on its own. And the nice thing about that is it's built in a way that's idempotent. So any business automation or anything that you build into your applications will be idempotent in the sense that you can deploy it to any OpenShift cluster and it will always look the same. So the OpenShift Container Platform provides you with one platform for traditional application and container-based applications because it's easy for you to pick up existing applications that you've already developed, containerize them, and then deploy them onto the OpenShift platform, whether they are stateful or stateless. It'll accelerate that application delivery that you are working on by streamlining the application flows, and it'll give that agility to every team to use the technology that they want. Yet there will be a full amount of control from your IT operations teams to make sure that there's comprehensive real-time visibility in what each team is doing, and every event that's automated within your workflows will be monitored and reported onto the operations team that will have full control over what you're busy building and doing in your application environment. And very important, the OpenShift Container Platform is backed by a growing partner community and an ecosystem that is flourishing with services that is being made available for you to easily adopt and to grow the functionality of your application without needing to go and develop specific features and functions on your own. So there's constantly new storage plugins, network plugins, and development tools that is being released through this ecosystem that makes your experience a lot faster and a lot easier without needing to invest your own time and money in going to build these things out. As we mentioned earlier, all of this happens in an environment that we refer to your infrastructure for definition as code, which means that your application is defined as a specific YAML spec or a JSON spec that is reusable, which means that you can build the spec and then copy snippets and parts out of the spec into new application specs, which makes your iteration and also new application development a lot easier, since you can just reuse things that you've already got in production and that you know and trust works well in the configuration that you've deployed it. You can reuse all of those statements inside a new application code or when you're upgrading older applications. It's idempotent, which means that it doesn't matter how many times you deploy the specification on any amount of clusters, whether that's on your on-premises cluster or whether that's in the cloud cluster, it'll always return the same result. It'll always have the expected result. And it is infinitely scalable because of that, because it means that you can theoretically deploy it on as many clusters as you want without ever needing to worry about the experience for your customers changing. But what happens if you would want to use more of our AWS native services, those services that are infinitely scalable, when you don't want to provision and manage your own MySQL database within your OpenShift environment, or if you would want to use a service like SQS instead of the MQTT that you need to manage inside of your OpenShift browser, OpenShift platform? Well, this is where the Service Broker steps in. AWS, together with the Red Hat OpenShift team, has built the AWS Service Broker. The AWS Service Broker is a native integration with the AWS Web Services API. And what that means is that your customers and your users of your platform, your OpenShift platform, will be able to natively provision AWS services without ever needing to leave the OpenShift platform. Your developers can use the catalog that is provided to them inside of OpenShift to provision services like RDS or EMR or SQS, and never need to open the AWS console or use the AWS CLI or any of those type of interactions to manage, provision, or destroy AWS services. The OpenShift platform will do that seamlessly and transparently without your developers needing any skill or knowledge in how to use or provision these AWS services. They only need to focus on their application and use the technology that they've gotten to know through deployment inside the OpenShift platform. And the OpenShift platform will natively translate their requests into something the AWS API control plane understands. We are very excited to let you know that we will be launching 10 services as a part of the AWS Service Broker at this year's reInvent Summit in November. And all of the 10 services that you see on screen right now will be generally available as part of our minimal viable product that you can provision through the AWS Service Broker using OpenShift. And we will have a short demo of this and how this works just after this presentation. The launch catalog is specific to AWS reInvent, but we also have a roadmap to make all of our AWS services available by next year. So we will have hopefully feature parity with all of our AWS services sometime next year. So in a quick summary, what does this really mean to you? With deeper integration into AWS services, you can save a lot of money and time and effort because you no longer need to manage your infrastructure manually. Things like RDS and messaging brokers and mail services and push notifications is no longer something that you need to manage, but is rather something that that you can offload and offset to the cloud management services like RDS that you've come to know and trust. And you can do all of this without ever needing to leave the confines of OpenShift. You have a global footprint, which allows you to deploy your applications in a trusted manner across the world and provide that high availability to your applications and to your customers to ensure that your customer experience is never broken down. With the integrated and automated workflow, you have an additional layer of security, and your applications can now be trusted and more secure than ever before. You're leveraging cloud-based security principles as well as best practice development security principles that is automated and built into your developer flow. And all of this comes together to make you more agile, and agile like cloud-native services and applications that is able to disrupt the industry that you're in. And then you have a vast partner ecosystem that allows you to adopt new services and technologies even faster without a significant investment in resources and money from your side, because the partner ecosystem will provide ready-to-use products that you can build on. We also have made it a lot easier for you to deploy OpenShift on AWS with the AWS Quick Start. The Quick Start allows you to deploy a reference architecture that is highly available of OpenShift in the AWS environment by the click of a button. You can go to the link on your screen right now and download the OpenShift or launch the OpenShift Quick Start directly into your account and start playing around with OCP on AWS. There's a comprehensive guide as well that will allow you to follow in this deployment process. It is a really simple and a very quick deployment, with OpenShift becoming ready to use in less than an hour. With that, I'm going to pass it over to Ryan, which will quickly take you through what an OpenShift deployment using the Quick Start will look like, as well as what it would look like when you use the AWS Service Broker with AWS OpenShift.
Right, Mandus, thank you very much for your time. Ryan here again. So as we discussed, we have built a QuickStart solution which is going to enable you to accelerate your deployment of the OpenShift platform onto AWS. I'm going to take you through a pre-recorded demo. The reason that we've pre-recorded this is the provisioning time is a little bit longer than the time that we have for this session. So essentially, I'm going to run you through the highlights of this provisioning process, and then I'll take you through the Service Broker platform that we are launching at reInvent later this year. Right. The QuickStart solution can be found on aws.amazon.com/QuickStart. Once you get to the specific OpenShift QuickStart, it's as simple as literally clicking on the deployment guide and following through the steps. It will require a registration process with Red Hat. So this is a very simple 5-minute registration process. It allows you to capture some detail, and once you have completed it, you'll have an account with the Red Hat platform. The OpenShift platform is licensed, so what we have arranged with the Red Hat team is to have a 90-day trial should you just want to test drive the platform. Alternatively, if you have a subscription to OpenShift, you can leverage that existing licensing within your platform. The deployment guide does walk you through this registration process from end to end. It also includes the exact commands you would need to register or link your existing subscriptions with the platform that you're about to launch. Alternatively, you can come through a graphical customer portal, and by drilling down through the subscriptions trail, you can get to your OpenShift subscription, whether it is a paid-for platform or a 30-day trial, as you see here, and you can get the pool ID that the Quick Start will require to launch this platform using this particular subscription. Right, let's jump back to the Quick Start solution itself. So as you can see, we've added in a collection of parameters here to simplify the environment that you're going to build. The QuickStart will cater for launching into an existing network infrastructure if you have one on AWS, or alternatively, it can provision an entirely new network for you. Just want to draw your attention to the subscription section over here, where you will add in the credentials for your the Red Hat portal, as well as the pool ID that would link it to the specific subscription you intend to use. Filling out the parameters takes only a few seconds. Once you've done that, click Launch. We do recommend that you tag these resources. This will help you in terms of identifying, billing, and tracking resources. And all of the resources launched by this QuickStart solution will inherit this tag. Off we go. Looks like nothing happened. Let's click on refresh. And you can see there we are seeing the CloudFormation side of this launching. Now, most development teams we anticipate will not have access to the AWS console. So this would be launched by probably a IT administrative team. Once it's up and running, the OpenShift portal can be managed by the development team and build things within the AWS account without even needing access to this console. The QuickStart solution does launch a nested set of stacks, so it will provision a network, and a separate stack will launch all of the OpenShift resources. Once everything is up and running, we can SSH into that platform, and we can actually start tracking what is going on over there. So what we're doing over here is very quickly looking at the logs on those systems while they are provisioning, and you can actually in real time see the automation provided by AWS CloudFormation in terms of provisioning the helper content that it needs, as well as installing all of the OpenShift components. That would be the master nodes, the infrastructure configuration, as well as an ETC database to track all of the object metadata within the applications, as well as the infrastructure. Right. Here you can see one of those scripts kicking off as part of the provisioning process. So it's a very, very minimal interaction. Fill in parameters, and off you go. It will provision your infrastructure for you. Right? We have accelerated this, so that build will usually take just over an hour. You can see over here, if we look at the timestamp, yeah, this particular build ran for just under 2 hours in terms of its provisioning cycle. Right. Logging into that OpenShift platform, the QuickStart will provide you with a URL for the Container Platform Management Portal, and you can log into it and start using your OpenShift Container Platform. What we're going to do is quickly run through the deployment of an example application which you can get off of Red Hat's Git repository. Right, just quickly creating some folders over here for the Kubernetes platform. Pulling down a Docker process, and what we're going to do is actually go along to Git and collect a sample application for deployment over here. Right, so registering the CLI with the instances or the platform that was launched by the CloudFormation process, logging in via CLI here. You could opt to do this via a graphical interface as well. So this is really a preference on your end, which would work best for you. Creating a new project name, we do recommend that collecting your applications or your building blocks into different projects. This will allow you to keep track of resources by project or by project team. The OpenShift platform also allows you to have role-based permission separations so that different development teams can work on different projects without having visibility of their own platforms. Right, so you can separate not just permission stacks, but also control the financial side of things, tracking the cost implications of certain projects. Obviously, the AWS tagging infrastructure helps you to add an additional layer on top of that. Right. just running from the command line, going and building a project over here and downloading a pre-created sample application from the Red Hat GitHub repository. We're obviously going to run this on top of a Red Hat Enterprise Linux platform. As you can see, the entire application has a Dockerfile detailing the exact infrastructure requirements for this application, and the Openshift platform will use that to provision all of the underlying components for the application, simplifying the workload for operations teams. So the development team can actually go and develop on a platform such as a laptop, take that exact same container environment and deploy it through OpenShift, and you will get a like-for-like experience from development through to production. Right, checking the status on this application, you can see that the components are busy coming up. Jumping across the graphical interface, you can, through the OpenShift platform, have a look at those same logs as they are being generated. You'll also note that there is an Events and a Details tab. The Details tab gives us a running count of the status, how long that has been running. We can go and see what are the actual OpenShift pods or building blocks that are running these components in the background. And we also have insight into the entire build process end to end. Right, at this stage, you can see the Docker registry being built and the pipeline actually going and building out those components. Any changes that are made are automatically detected by the Kubernetes orchestration layer and pushed into the application. I'll show you that several times throughout the next set of demonstrations. So there you can see there was the original sandbox application, and let's see if we can get some logs out of here. There is at times a delay on the logs presenting. Depending on the log label that you've selected, you may get no logging unless there is an error in the environment. Right? You can see that we are provisioning a persistent storage platform for this application. So again, leveraging Kubernetes to manage that orchestration. If your application requires persistent storage, you can define that storage requirement through the Docker configuration, and the storage will be provisioned and allocated to those systems. As you can see over here from the Events tab, you can actually see the image being pulled down, image being processed within OpenShift, as well as the container platform being spun up and applications being launched into the environment. Still no errors coming through in the logs, that's good. Jumping across the terminal, this will give you terminal access directly to the system. Let's see if we can interface with the application. I don't know what the port is, let's quickly go back and check. There we go, exposing it on port 8080. Okay. And we are getting a very, very minimalistic interaction with the application. You can see we're getting some positive response codes being logged there. The application that we're pulling from Git does have detailed descriptions as to how you can integrate this with other applications. Obviously, we're not going to go through that process today. Right, we're going to quickly go and grab the services that are running on that system and just run that within our platform. And as you can see, there is a private IP address allocated to the application. You can see port 8080. There is no external IP address allocation as this. So what we have the ability to do is expose this through OpenShift. And essentially what this does is it takes the internal resource IPs and links them to a DNS namespace so that your applications can link to that via DNS. Right, and there you can see we've got a DNS namespace created for this particular application deployment. Let's quickly go and connect to that URL. What you'll notice within the application itself on the top right-hand corner, that namespace is duplicated over there. So development teams don't have to jump backwards and forwards between interfaces. And then you can see we're actually talking to that time application that has been deployed. No network configuration required, no launching of virtual systems, the automation and orchestration kicking in to build all of the underlying building blocks for the application. Right. Ability to see the number of times that this system has been launched. We can dynamically scale that up or down. If we change that to, I want 3 systems running this application, the automation kicks in and goes and provisions additional infrastructure resources and deploys the application on top of that. So really giving you that flexibility of scaling up and down. Also, should a system fail for whatever reason, if there's any underlying infrastructure problems, scale up and remove the ones that were problematic. Rolling out new versions of the application are incredibly seamless. Literally taking the new application, pushing it in, and the Kubernetes platform will provision the new resources, tear down the old ones. Coming back to AWS Quick Start, this is certainly not the only Quick Start we have. You'll find this particular one under the DevOps section, but there is an extensive repertoire of Quick Start solutions you can use to accelerate your deployment process. The Quick Starts are open sourced, so please feel free to go to the Quick Start. They're all backed by CloudFormation. You can go into the Git repos for them. You can fork these repositories and you can make these your own. You can adapt them to your requirements. The QuickStart solution is coupled with a comprehensive deployment guide, which not only discusses the deployment of this, but also the architectural background, which is built around best practice. And as you can see, the Git repository contains all of the building blocks. So that is the CloudFormation templates to launch, the OpenShift components, the scripts required to deploy in there, as well as the other infrastructure building blocks, such as the AWS VPC network infrastructure that is going to be required should you want to build a completely new network as opposed to launch into an existing one. The Git repo does allow you to actually go and log issues and give us insight into if you see a requirement to change anything, and our QuickStart team will respond to that in terms of modifying the solution to cater for these. Right. I'm super excited about this particular QuickStart purely because of the acceleration that it provides us in terms of getting OpenShift up and running into a customer environment, even if it is just for a short-term workload such as a POC or a long-term production platform. Right. What I'm going to do is I'm going to very quickly take you into the future, where we're headed with OpenShift, and that is for customers who are not only looking at taking OpenShift and using it as they were on premise, but also how does a customer take OpenShift and combine it with the AWS Service Broker in terms of launching resources into AWS itself. So as discussed before, the AWS Service Broker is an integrated component into OpenShift. And what I'm going to do is I'm going to take you through a very quick demonstration of that platform. And I seem to be trapped in the same presentation. I apologize profusely. Right, there we go. So this is the AWS Service Broker. As you can see, it integrates into the OpenShift platform. It runs on top of a service catalog, and you'll note that the service catalog does not only contain components relevant to AWS. As discussed in the previous demo, you do want to create a project for the purpose of keeping all of your resources neatly together. This is one of the service plans that we built for reInvent, an SQS platform. And as you can see over here, when you launch a particular product that we've provisioned through here, it does ask you for all of the parameters, the inputs that. But I don't want people to go and launch the AWS keys in that manually. You can see it was prompting for them over there. What we have the ability to do is go and create a YAML-based secrets file, and you can ingest the AWS secrets, the CloudFormation ARN role that you're going to use for provisioning these, and store them within the OpenShift platform for reusability. So to cut down on unnecessary typing, you don't need to simply do these objects over there. You can actually go and add in any parameter needed by the configuration. Once you've created that secrets file, we're going to come to the broker configuration, and what we will do is very quickly go and add in a section underneath the broker so that the broker understands it needs to use this secrets configuration. So we're just going to go and say secrets and add in the configuration for where those secrets are stored. Right, you'll notice that the application name, in this case the SQS broker, is linked here. So this will be used by this broker specifically. If you want to reuse these secrets for other broker platforms, you'd simply go and add them in there and list them specifically. So you've got control over which applications will have which simplifications added to them. Right, so there is the Ansible platform kicking off and building out that resource in the environment. You'll notice that there are two builds. Something interesting seems to have happened there. Let's quickly go into the logs and see why we have. And you'll notice over there, at the time of this change, the ETC cluster wasn't available. Let's quickly go to ETC. Looking at the ETC logging, everything does look happy over there. Let's go back to that build. Okay, and as you can see here, that the automation in the background doesn't just provide you with a provisioning strategy, it also has an evolved logic to cater for, should something fail, it will automatically retry and attempt a recovery of that, which in this case it has. Right. Here you can see the deployment controller. This is managing the deployment of that application through a combination of Ansible playbooks and container files. Got our environment up. Let's quickly bounce back to that service broker, and here you can see the application is up and running. What we've also done is created a collection of sample applications which you can attach to these service broker components. All right, still seeing the secret keys over there. Let's quickly go and do a refresh and wait for that deployment to complete. There you can see the secrets not only being found but being linked to that application. So when we launch that application in the future, it shouldn't require the input of those security keys. And there you can see now it is simply prompting for the project you want to link it to, as well as which region you would like to deploy this in. and various configurations around the specific application. We are not going to do a binding at this stage. That way I can show you the binding process post-launch. Let's drill down into the project. Notice we're building a SQS queue here inside of AWS without in any way interacting with the AWS console, without having any intimate knowledge of those processes. Here you can see from a CloudFormation perspective the resources being spun up in the background. Again, development teams would not need access to the AWS console. That's just showing you what's going on in the background there. Next, what we'll do is create a binding over here. The binding process will allow us to link or provide components for linking of applications. As I said, there's a sample application. We'll go launch the sample application very quickly, put it into the same project so that we can track that from not only a resource but also a cost perspective. The sample application is very simply a collection of API calls through to the resources, just to validate that they are working as expected. Right. There is no binding in place between the SQS queue which we provisioned in this application, so this should fail until we create that binding. And yes, you can see that has not succeeded. All right, let's quickly go back to the application and create a binding. Right, going into the view, the bindings are hidden. You can reveal them. We're not, because there's some sensitive data over here. What we're going to do is link that to the sample application, and that will provide things like DNS namespaces, endpoints, ports through to the application, depending what has been exposed through that binding. Now, if we go back to that sample application, the Kubernetes platform will automatically replace that system, and you'll see there we are seeing successful API calls through to that queue once the binding is in place. Yes, you can do bindings to multiple applications. It is a one-to-many platform. The bindings can be removed and updated. And as you can see over here, the new resources provisioned and the older resources are torn down and removed from the platform. At this stage, we have got 10 applications ranging through a collection of database and other components. Looking at EMR over here, in each of these service plans, we have catered for a production collection which has got minimalistic parameters. You can run it according to a best practice standard, or you can go for a customized solution where you can tailor the parameters to what is relevant to your business. Some of these solutions your teams may not be very intimate with, so one of the things that we were concerned about is how do you wrap your head around what are the parameters and how are they relevant to you. So we will be open sourcing all of these, and in the Git repository, which we'll be launching at reInvent, we will have all of the building blocks for these service plans, so the Ansible playbooks that flesh them out, as well as detailed parameter descriptions, whether they are absolutely required, whether they're optional. We have also tied these as closely as possible to the API calls. So if you're going back to the Amazon Web Services documentation pages, you can look up each of these applications and see how these parameters interface with each other. Failing that, feel free to reach out to AWS support if you absolutely get stuck. Right. The components, we have tried to simplify this as much as possible, so you'll see a very large usage of default parameters, which by all means feel free to change, but they're there so that you can accelerate your deployment process as much as possible. Right, the Amazon Web Services Service Broker integrated into OpenShift running on top of AWS itself. We are launching this at reInvent, and there will be further feature launches as we go ahead. Right, we've got a couple of minutes left, and let's jump into, let's see if anybody has any questions that we can have a look at. A couple of questions coming through already. There is a licensing question here. Yes, OpenShift does have a licensing platform. The AWS requirements have no licensing, but the OpenShift platform does have a licensing model. Licensing is exactly the same as you would have in an on-premise environment. I would recommend that you reach out to your Red Hat licensing team to get the nitty-gritties of that. In terms of the demo that we ran through today, that was based on a 30-day trial. The deployment guide for the QuickStart does contain information as to how to get access to that 30-day trial should you just want to test drive the solution. I see there is a follow-up question regarding that 30-day trial. During the 30-day trial, will I need to change anything on the AWS side of things? The QuickStart solution will, when you provision it, have a linking to that subscription. So what you could do is you could tear down the QuickStart, launch it again should you desire, and then just define the pool ID for your updated licensing. Alternatively, what you can do is once the resources have provisioned, you can via the command line go and update the licensing and change the pool to update the licensing without tearing down that infrastructure. If you recall in the presentation, there is a set of commands inside the deployment guide that detail the exact commands for deregistering as well as registering the infrastructure and linking it through to that licensing model. Right, let's see a couple of the other questions that have come through here. One of the questions that's come through is, why would I opt to use OpenShift as a licensed product when I could leverage Kubernetes as a potentially more cost-effective solution? To answer that question directly, we do have to acknowledge that Kubernetes is a project. Yes, it is free, and yes, it is very, very widely used in the industry, but it essentially is an orchestration platform for the application. What OpenShift as a product brings to the picture is taking everything that Kubernetes provides and adds an additional layer of management on top of it, providing control over several things that Kubernetes does not cater for, and traditionally if you're using Kubernetes you'd have to build and provision those yourself. So OpenShift brings in role-based securities for your development teams or your IT operations teams. It provides monitoring beyond the application itself, monitoring with inside the infrastructure that you're launching. So those benefits provide an acceleration into the market. A lot of our customers are looking for, I don't want to invest time in building out these building blocks that I'd need in my business over and above Kubernetes. So very attractive for them to go into OpenShift, provision OpenShift, and get the immediate benefit from that, obviously with a licensing implication over there. That is unfortunately all we have time for in terms of the Q&A session at this time. I'm going to thank you very much all for attending.